Okay, so this is my progress so far. This is the 6502 board that I've been working on through this kind of project by a guy called Ben Eater. Up at the top over here is the clock for the computer. And I think that I've got some trouble with the clock here somewhere, but it's a clock that can pulse using a variable resistor, so I can change how fast the clock speed goes, or I can switch over to kind of manual and literally press this button and it will tick each time, and then this light at the end would be connected up. This would be the actual pulse, and that would be connected up all the way down to this white wire. However, just recently I've decided to take that out and drop in this crystal, which is a 1 megahertz crystal, which allows the clock or the computer to run at 1 megahertz. So what we've got is this would be the 6502, and this I've already had troubles with. So this is the original 6502 chip, and for some reason I could talk to it, but it wouldn't say it was writing, and I needed it to kind of put a high pin. I think it was one of these to say it was writing, so that failed. After a lot of hunting around, I eventually found that I could use the upgraded chip, which is a 65816, and it boots in emulator mode, which means it behaves exactly like a 6502, so long as I have this wire plugged in. That's the only difference. And then next to it I have the EEPROM. So this is the EEPROM. This is where I yank the chip out of the board and I program it using assembly to make it do something, and then this chip talks to this chip over the data lines, which are these blue lines here and the address lines here. So this is a 16-bit data and 32-bit addressing. No, 16-bit addressing, 8-bit data. And then that talks to this chip, which is the effectively controls I/O. So it has two ports, two 8-bit ports. So this is one of the 8-bit ports, and it's the other 8-bit port. And this 8-bit port is talking to this LCD screen. And the project is basically to write hello world in assembly on this, and have this read that chip and then control this, which controls the lights. And then finally over here, I've got 16K of RAM, and in fact I'm only using 8K of it. And this allows me to do write function calls on the EEPROM and make the function, do a function call where the assembly would jump, and then it needs to know where to jump back to. And it stores a stack pointer, and this is where it stores it in the RAM. So when we talk about RAM, being able to write to RAM, this is the RAM chip. So 16K, or even 8K rather. And then, so yeah, it's 1 megahertz. This is just an AND gate to do a bit more logic. Reset button over here. Capacitor, I don't really understand why the capacitors have worked, but so let's plug this in, and hopefully it should work. I'm gonna plug it straight in. I do get some bugs occasionally, which means I probably shouldn't make computers. Start it up, and then I need to hit the reset button, and there we go. Holy mackerel, that worked first time. So I hit reset. It's running at 1 megahertz, which is pretty fast compared to the clock that I've written. Yeah, prints hello world, and that's a function call in there, so that's pretty cool. If I pull it out and try again, it's working. I don't know why it's working so well this time, but occasionally it would just lose letters, which is very frustrating. But anyway, yeah, my 6502. So the next part is to probably, I think I'm adding some buttons to control it somehow. But yeah, it'd be pretty cool if I could wire this up to like a bigger screen with more rows. So, you know, I don't know how many characters, but yeah. Anyway, cool.